Hello students, welcome back. Previously we went through the definition of the subgroup and the subgroup condition. And then we went through a couple of examples, a trivial example and a non-trivial example, but still simple. Now let's consider a little bit harder examples. Let G be a group and H and K be subgroups. Is the union also a subgroup? Yes or no? If yes, you have to prove it. If no, then you have to provide a counterexample. How about the intersection? Again, take a guess. If yes, you have to prove it. If no, then you have to provide a counterexample. If you want to prove it, that's how you do it. Well defined inside that candidate, identity, and inverse. These two are going to be easier, but this may take some effort. How about the next example? Even harder. Let's H and K be subgroups of an abelian group. A subset defined like this, H plus K form, or the element of G that can be written in H plus K form, where H is from capital H and K is from capital K. It's a subset, yes, but is it a subgroup? Take a guess, prove it or disprove it. If yes, you have to prove it. If no, then you have to provide a counterexample. And that's for the abelian group. And this is for non-abelian groups. So here I use addition notation. Here, just multiplication notation. So all the elements of G that can be written in terms of 8 times K form, where H is from capital H and K is from capital K. That's a subset, but is it a subgroup? Good question. Let's consider these a little bit later. Let's see. Any guess here? It turns out the answer is no. Can you find a counterexample? In this case, it'll turn out to be yes, but you have to prove it. But I'm not giving away anything here because this is going to be a homework problem. Both of them, both questions. Let's see, as for the counterexample, I'll leave that to you. As for the proof, here's a suggestion. We have to establish these three, right? We have to establish these three. So X and Y are coming from H intersection K. Then X star Y also a member of H intersection K. Well, that's what you have to establish. Let's see. This one S2 is going to be relatively simple. Let's see, the identity exists, and it exists in G, but then again, H is a subgroup, K is also a subgroup. So the identity must exist in H, and also in K, and also in G, but the identity is identity. There's only one identity there. because they are subgroups. Therefore, belong to the intersection. You can write like this. The idea is in H and also in K, consequently in the intersection. Make sense? Let me give you a similar hint one more time for this. Okay, so X belongs to the intersection. Therefore, X belongs to H and also X belongs to K. X belongs to H. Therefore, what can I conclude? X inverse belongs to H. Does it make sense? Because H is a subgroup. How about K? Can you say the same thing? K is a subgroup, so any member of the subgroup has the inverse also in the subgroup. Exactly the same thing as H. Putting together, what do you get? X inverse belongs to H and also in K. So it's the same idea. It's in H and it's in K. I use this brace notation because there are so many and, but I could have separated in a little bit different manner, in a little bit less efficient manner. But I'm giving you hints basically. In H, in K, consequently in the intersection. In H and also in K, consequently in the intersection. But how do you determine whether this inverse is in H? The inverse is in K. It comes from X is in H and also X is in K. If you don't like this brace notation here, I could rewrite like this. So, okay, I could rewrite like this. And what conclusion can I draw here? X belongs to H, therefore X inverse belongs to H, X inverse belongs to K because of the ladder, you see. This one here, as I highlighted in blue, will give me this blue conclusion. This one here, as I highlighted in green, will give me the green conclusion. So X inverse belong to what? Oops. H intersection K. It's in H and also it's in K. So blue gives me blue, green gives me green, and they are joined by AND. Which do you like better? On the second thought, I like this one better than this one down here, especially with the color coding. And let's not erase any of those. They're both valid. Now, can you use similar argument to this one? In conclusion, you have to say x star y is in H, and also x star y is in K. Consequently, it belongs to the intersection. How do you argue that? Okay, all right. That must have been a sufficient hint. Yeah, I'll open those up. This one is rather trivial. And then this one had a bit of thinking. And then that may be helpful doing the first. And as for creating a counterexample, okay, that's up to you. And similar consideration for a little bit harder problems. For abelian groups, the answer will turn out to be yes, but you have to prove it. In other words, you have to prove those S1, S2, and S3. Good luck. Similar idea. And finally, for non-abelian groups, the answer will turn out to be no. Okay, there's a fundamental difference between abelian groups and non-abelian groups. Can you find a counterexample? Oh, good question. You gotta know some examples of non-abelian groups to begin with in order to create a counterexample. Good luck about that. That could be a bit of a challenge, but I'm gonna leave both of them as homeworks. One final comment. This H plus K is a superset of H intersection K. So this H plus K is a subgroup that contains H intersection K. And how do you prove that? Well, let me give you a hint. H plus E. H can be written as H plus E. Like this, because E belongs to K. Similarly, K is E plus K, and that'll belong to H plus K. I guess I'm giving away too much. So it turns out H union K is a subset of H plus K, but this one is not a group in general, but this one is. It'll turn out that's the smallest subgroup that contains H union K. How do you prove that? Good question. Go back to the previous problem. It turns out that H intersection K is the largest subgroup that includes both H and K, that are included in both H and K. That much, this one is clear because this is the largest subset that's included in both H and K. And that happens to be a subgroup. So yeah, that's going to be the largest subgroup as well. So that one is a little bit easier to understand. This one may be a little bit harder to consider. Okay, so many open-ended questions, but they're all homework problems. I hope these discussions helped.